Hello everyone, my name is Lucky Chitupoli and today I'm going to be teaching you geometric sequences. So first of all, what even is a sequence? Well, a sequence is an ordered list of numbers. For example, a sequence can be 2, 4, 6, 8, 10, 12, and so on. Today, however, we're going to be discussing geometric sequences, which are a specific type of sequence. Geometric sequences are sequences made by multiplying by the same value each time. To elaborate, in a geometric sequence, each successive number is a fixed multiple of the term prior to it. So let's start off with a simple example. We'll begin with the number 1. Let's multiply 1 with 5. So we get 1 times 5 equals 5. Next we multiply that product of 5 with another 5. So we get 5 times 5 equals 25. Once again, we multiply that product with another 5. So from here we'll get 25 times 5 equals 125. And we can keep going on and on from here. For this pattern, we can create a formula. Well, to start off, we call our first term a sub 1. In this case, a sub 1 equals 1, because 1 is our first term. Next, we find the common ratio between the terms. In this case, our common ratio is 5 because we're multiplying each term by 5. In our case, if we were only given the first term 1 and the common ratio 5, and we were supposed to find the next two terms, we just multiply each term from 1 by 5 to get 1, 5, 25, 125 to 625. On another note, a common misconception some people believe is that they may think that a sequence and a series are the same thing. However, a series is the sum of a sequence. So, if the previous geometric sequence we were going through was actually a series, the series would be 1 plus 5 plus 25 plus 125 plus 625. So, back to the geometric sequence, let's go do a real world practice problem. So, let's say we're going on an amusement park ride where the height of the ride goes twice as high each spin. Now, let's imagine that the height of the first spin is 5 feet above the ground and the round goes for multiple spins. In this case, our a sub 1 equals 5 feet, and our common ratio equals 2 because you're multiplying each spin's height by 2. Let's list this out on a table. So we know that on spin 1, the height of the ride is 5 feet. Next, for spin number 2, the height of the ride is 5 feet times 2, which is 10 feet. Next, on the third spin, the height of the ride would be 5 feet times 2 times 2, which is 20 feet. And then next on the fourth spin, the height of the ride would be 5 feet times 2 times 2 times 2, which would equal 40 feet. Instead of creating a whole table and spending a lot of time to list out how high each spin is, we can instead create a formula. So if we wanted to find how high the ride is on the nth spin, we could say that nth spin equals a sub 1 times the common ratio to the power of n minus 1. So if we were to plug in our variables for the nth spin, our equation would be a sub n equals 5 times 2 to the power of n minus 1. And you use n minus 1 because you're multiplying by the previous term. So, if we were to find the height on the 7th spin, our equation would be a sub 7 equals a sub 1 times 2 to the 7 minus 1 power. Simplified, that would be a sub 7 equals 5 times 2 to the 6th power, and that would equal 320 feet. So from this, we know that on the 7th spin of the amusement park ride, the height would be 320 feet. Thank you for listening to my presentation about geometric sequences.